river environments, and we're looking at the hydrological cycle, which, as the name suggests, is all to do with water. Let's start with the definition. So the hydrological cycle is the global circulation of water. It is a closed system made up of both stores and transfers, and we'll be looking at what those stores and transfers are in a great amount of detail. But what do we mean by a closed system? Well, it basically means that water can neither leave or enter the Earth's surface or atmosphere. What do we mean by transfer? Well, that's the movement of water between stores, and there's lots of different transfers you need to know about. The first one is evaporation. Evaporation is when heat energy causes the temperature of the water to rise until it turns into steam and forms clouds. Next up is transpiration. If you do biology, you'll know all about this. It's where plants absorb water at their roots and then they transpire that water out of their leaves. And I'm trying very hard not to mention stomata, etc., because as geographers, you just need to know that that water evaporates from the surface of the plant's leaves. A term which you may have heard is the combination of those two terms, and that is evapotranspiration. Condensation now, which is the opposite of evaporation, that's when that water vapour cools and condenses, turning back into a liquid, and that's what you often find occurring at clouds. Now, precipitation, that's effectively when water transfers itself from the atmosphere to the Earth's surface. So it includes things such as snow, rain, hail, that sort of thing. Slightly more complicated now, surface runoff, that's when water falls as rain and then it runs across the Earth's surface into surrounding streams and rivers. Through flow is when water drains through the soil due to the force of gravity, and again that water will collect in streams and rivers. Groundwater flow occurs in rocks of the aquifer. Remember, an aquifer is a porous rock that allows water to drain through it, and in this way water will reach seas, rivers and lakes. So those are the different types of transfers you need to know about. But what sort of human factors can affect the amount of transfer that occurs? Well, the first main one is urbanisation. When we build cities and towns and we pave and we concrete and we tarmac the surface of the earth, that basically increases the amount of runoff that occurs, because obviously that water is not draining into the soil, it's not draining into the aquifers in the same way. And you will find that urbanisation does lead to an increase in the speed at which these water transfers occurs. Deforestation, that's another human activity. It means cutting down trees. Remember, we cut down those trees for building materials, to provide land for farming, fuel, etc. What happens when we deforest is we lose the topsoil, because it means we no longer have the tree roots holding down the soil, and again that will increase surface runoff. We've looked at human factors, but what about physical factors which affect water transfers? So the first one is rock type. You'll find that non-porous rocks will allow water to run off far more quickly because that water won't be soaking through the rock. Vegetation will also have a large effect. If you have more trees, then that will increase the rates of rain interception, as well as increasing the rates of transpiration, and as a consequence, evapotranspiration. We'll touch a little bit on storage here, because the third physical factor which will affect water transfers is global warming. As temperatures increase, you will find that the stores of ice and snow reduce. However, there'll be an increased transfer to our seas and oceans due to increased precipitation rates. We will now deal with water stores, and that's where water is stored within the hydrological cycle, and that falls into three broad categories. That will be land, sea and the atmosphere. So we'll now go through those in a lot more detail. First of all, lakes. Now, water is stored in lakes because it has a bottom made up of a non-porous rock, which means the water can't drain away. Rivers, hopefully, are quite self-explanatory, as well as the sea. You find that soil is a good store of water because that water can't percolate through to the bedrock. Other examples of good water stores that you need to mention in your exam are groundwater, surface water, clouds, ice, and then that aquifer, which, remember, is a porous rock that allows water to drain through it. Sometimes it's useful to see a pictorial representation so you can understand how all the stores and transfers are linked. So because it's a cycle, it doesn't really matter where you start. But let's have a look down here. So heat energy causes the water's temperature to rise, it becomes steam, it evaporates up to form clouds. We said that any water coming from the clouds in the form of hail, rain, snow is examples of precipitation. So that's what we can see here. We can see ice falling over there. Through surface runoff, where that water runs over the Earth's surface, we know that water, due to gravity, will lead to rivers, lakes, streams, etc. So we can see how the water is returning to the sea as a store. Vegetation interception we already talked about, which is a physical factor affecting water transfers. Those trees will be absorbing that water at their roots, Transpiration will be occurring as a result of that. Then down here we have examples showing through flow and groundwater flow. Remember, through flow is due to gravity, where water drains through the soil until it reaches either a stream or a river. Groundwater flow occurs in rocks of the aquifer. Remember, that's your permeable rock, and involves the transfer of water to lakes, rivers and the sea. So you can't see absolutely everything on this diagram, but I'm hoping you understand how water is stored and how that water is transferred. And remember, this is a closed system. Water is neither allowed to leave or enter the Earth's surface and atmosphere. Now we're going to move on to the drainage basin. What is a drainage basin? Well, it is an area of land drained by a river. It's an open system, and that means that the amount of water varies over time due to changes in external inputs and outputs. So what sort of inputs are there of a drainage basin? The first one, which is probably the least obvious, is energy from the sun. But then let's think about, how would water be added to a drainage basin? Well, precipitation is a good method. So remember, that's anything that falls from the sky, rainfall, snow, hail, etc. As well as water from tributary basins. Remember, a tributary is a small river which joins the main river channel. What about the outputs of a drainage basin now? So how does water leave the drainage basin? Transpiration and evapotranspiration is going to be important here. Remember, transpiration occurs from the leaves of plants, as well as the river's discharge, which we will spend an awful lot of this video discussing. Just one thing to point out, a drainage basin is very different from a hydrological cycle in that a drainage basin is an open system. As I said previously, the amount of water that enters and leaves varies, unlike the hydrological cycle where the total amount of water remains constant. Now we're going to talk about characteristics and features of the drainage basin. So remember again, that's the area of land drained by a river. The first thing you need to be aware of is the source, and that is the origin of the river. Next up, the watershed. That is the boundary of the drainage basin. It's a raised piece of land which separates one drainage basin from another. The channel network is, if you think about a river, it's covered by a network of tributaries. So that channel network is that area of land covered by both the river and its tributaries. The mouth of the river is the point where the river ends, and that tends to be at a sea or an ocean. And finally, catchment, that is the area within the drainage basin. Now there are three different types of drainage basin. First up, those that collect water and deliver it directly to the sea, so they'll be the ones you're most familiar with. Some drainage basins form part of much larger river drainage basins. A good example of this is the River Negro, which is in South America. Now you'll find that its drainage basin forms part of the huge drainage basin of the River Amazon. And then finally, some drainage basins don't drain to the sea or ocean. Instead, they drain to inland seas or lakes, and a good example of this is Lake Victoria in Africa. Next up, river discharge. As we've already mentioned that as being an output of a drainage basin, the river's discharge is the volume of water carried by a river at any one place. So what factors affect the river's discharge? Well, first of all, the most obvious ones are things like precipitation, and particularly rainfall will affect river's discharge. So remember, that's the volume of water flowing at any one particular place. Obviously, if it rains more, there will be a greater river discharge. Second up is vegetation. Now, if vegetation is cut away, it exposes bare rock. This reduces the time taken for the water to be soaked up, leading to an increase in the river's discharge. The good thing about trees and other vegetation is their presence intercepts that rainfall usually, and therefore delays that rain reaching the ground and has the subsequent effect of reducing the river's discharge. Other factors which affect the river's discharge include soil type, length and width of river, and the number of tributaries, so small rivers which join that main river channel. In terms of human activity, urbanisation has a detrimental effect and will increase river's discharge. This is because urbanisation, so building of settlements, increases the rate of surface runoff and therefore decreases the lag time. This will increase the peak in river discharge. Urbanisation also automatically means that vegetation will be cut down. So as I was just saying, that means that there'll be less interception of rainfall, meaning that there won't be that delay in that water reaching the ground. So you'll end up with more surface runoff and greater river discharge. Now we'll turn our attention to river regimes. First of all, let's start with the definition of a river regime, and this is the way in which the river's discharge changes over time. Remember that the river's discharge is the volume of water carried by a river at any one place. So we need to consider why would that volume increase or decrease at any particular point in time. We do also like to look at it over the course of a year so we can make predictions and understand more about the behaviour of a river at any particular season or point in time. So if we consider the sort of things which will increase the river's discharge, well, first of all, heavy precipitation, so heavy rainfall, what that means is that the ground gets saturated very quickly, which increases surface runoff, meaning that there's a shorter lag time, so that water that falls from the sky will flow directly into the river, so that will influence the river regime in that way, increasing the river's discharge. If we increase the temperature, so hotter days, there'll be more evapotranspiration, so that will remove water from the river. What about vegetation now, so more biotic factors? Well, vegetation such as trees will intercept that rainfall, meaning that there's a bit of a delay in that rain reaching the ground. So you'll get slower infiltration of the ground, and that will increase the lag time. So that means there'll be a delay in that water reaching the river. In terms of land use and humans' activity, this can actually alter the river regime in opposing ways. So for example, humans might put in drainage channels, more canals. So obviously that will take water away from the river. However, urbanization generally, and by that I mean building settlements, what that means is there's less ground for that water to soak into, to infiltrate. So in this situation, you'll end up with more surface runoff, and that water will wash into the rivers, meaning that there's a decreased lag time. So look at it from 2 points of view. Either human behaviours which will divert that water away into canals, into drainage channels, or the fact that we're building more, concreting our surfaces, meaning that you get more surface runoff and therefore greater river discharge. And in that latter situation, you will find that that creates more of a flashy river regime. Other things humans do could include water abstraction, and that's where humans remove water from the river for particular uses. That could be an industry, that could be to water crops, so irrigation, or that could even be for consumption purposes, washing, cleaning, etc. And then lastly, dams. Again, this is something that is human built. Dams are often built in order to trap water within a reservoir, and then through the process of HEP, so that's hydroelectric power, these dams are used to generate power for our homes. Again, that will affect the river's regime. So broadly speaking, if you're asked to describe the factors which affect river regime, let's talk about precipitation, let's talk about temperature, let's talk about vegetation, land use, water abstraction and dams, and break your answer up into those various categories and provide the extra details that I've already given you previously in this video. A storm hydrograph, graph which shows how a river's discharge changes over time, and that's typically before, during or after a storm event. Why are storm hydrographs so useful? Because they provide valuable insights into the relationship between rainfall and river flow, and that's important because lots of people build their homes within drainage basins, and a huge amount of time and money is spent building these homes. So storm hydrographs provide valuable insights that enable you to predict floods and understand how bad those floods will be, so that people can make informed decisions about what to do, whether they can stay in their homes and put out sandbags or whether they need to leave. But now we're going to go onto my iPad and actually have a look more closely at a storm hydrograph. So let's have a look at a typical storm hydrograph. So typically you'll find three things on these graphs. To the right hand side we can see precipitation, so that tends to be rainfall, and that's given in millimetres. On the left hand side we're looking at river discharge, so that's the volume of water flowing through the river at any one particular place. And then at the bottom we have a time scale. Now there are two types of flow which affect the discharge of a river in a storm hydrograph. First of all, we have the base flow, which is the normal discharge of the river, which we can see bottom right in the baby blue spotty section. That is the river's usual discharge. With the storm flow, which we can see on the key on the left hand side, this is when you're going to see a huge increase in the river's discharge. That tends to be in line with a huge amount of precipitation. And so we call the storm flow the extra discharge of a river, which results from a storm. So as I've already said, storm hydrographs show river discharge, precipitation, and time. They have a base flow, which is the normal discharge of a river, as well as a storm flow, which is the extra discharge of a river, which results from a storm. Now we're going to look at the features of different storm hydrographs. So we'll start by looking at this portion where the bar chart is. We can see that this is the peak rainfall or peak precipitation. As you might imagine, this is the maximum rainfall that occurs. Moving over to the graph line as opposed to the bar chart, always has this characteristic shape. You can see this portion of the graph where it is steeply increasing that gradient. We call that the rising limb, and this is the increase of river discharge. It doesn't necessarily have to occur straight after precipitation. Then you have the peak discharge here, which is the maximum discharge. Remember, you will see that delay because it does take time for the water to find its way to the river. You may also see this described as peak flow. The thing with geography is there's lots of names for the same thing. Because there is that delay between the peak precipitation or peak rainfall and the peak discharge, due to that time taken for the water to flow into the rivers, we call that delay the lag time. So we've dealt with peak rainfall, rising limb, lag time, peak discharge, but what about this falling limb? We can see that negative gradient of the graph line. This is known as the falling limb, and what it's trying to say is that as that storm precipitation levels decrease, in turn, river discharge will decrease because less water will be entering the rivers. And then last up, base flow, we can see down here. That's when the river discharge returns to normal. So what factors affect the shape of storm hydrographs? Well, firstly, the amount of precipitation or rainfall. Obviously, the higher the rainfall, the greater the river discharge. Next up, human activities. Urbanization and deforestation both increase river discharge, and that's because of increased surface runoff. The size of the drainage basin will also affect the storm hydrograph, and actually you find that large drainage basins are associated with less discharge. Small drainage basins are associated with more discharge, which might seem a little counterintuitive. Rock type also has an effect. If you have an impermeable rock like granite, you will see more discharge because that water is not going to soak in. If you have a permeable rock like limestone, you'll get less discharge. So do be prepared to compare these various factors. We can sometimes describe these hydrograph shapes in terms of whether they're flashy storm hydrographs or if they're subdued storm hydrographs. So the classic shape we have here is for a flashy storm hydrograph. We'll talk about the various characteristics shortly. If this graph changed a little bit in shape, so it was more like this, that would be what we would call a subdued storm hydrograph. That's because we have a longer lag time, a lower peak, and a gently sloping rising limb, as we can see here. So yeah, longer lag time, lower peak, discharge peak, and a gently sloping rising limb. And we'll talk about the reasons as to why you get the flashy storm hydrograph versus the subdued storm hydrograph right now. So our flashy storm hydrograph, we know we're going to have a short lag time. We'll have a high peak discharge and a steep rising limb. So those are all descriptions of the graph we would see. Why do we get these various features that we see on the graph? Well, for a number of reasons. You could have had an intense storm or rapid snow melt, steep slopes. So if we consider the geology, steep slopes mean that we'll get lots of runoff into those rivers. A small drainage basin will also give rise to flashy storm hydrographs. In terms of human behaviours, deforestation and urbanisation will increase surface runoff and therefore mean that you're more likely to get a flashy storm hydrograph. So there's lots of different factors you can talk about affecting the shape. If we look at the subdued storm hydrograph then, what do we expect to see on the graph this time? As I've already said, you'll have a longer lag time, lower peak discharge, shallower rising limb. So the reasons for that subdued storm hydrograph will be opposite to the ones we talked about in the flashy one. So rather than an intense storm, we would talk about steady rainfall, gentle slopes, large drainage basins, lots of vegetation. Because remember that vegetation will intercept that rainfall and delay that water reaching the rivers. So let's look at some past paper questions. We're being asked to study figure 1b and identify the feature of the storm hydrograph labelled X. So here's figure 1b. What is X? I'm hoping you can see that that is the peak rainfall. It's the top of the bar chart. Next question, study figure 1a. Suggest 2 reasons for the different storm hydrograph shapes, 4 marks. So here are our storm hydrographs. I'm hoping you can see this is a flashy storm hydrograph. We've got that shorter lag time, the higher peak discharge, the steep rising limb. This is a subdued storm hydrograph. We've got a much lower peak discharge, a shallower rising limb, and a longer lag time. So we are going to state those differences and then give a reason for it. So in the first storm hydrograph, there is a shorter lag time, and that could be due to urbanisation and deforestation, increasing surface runoff, and means less interception takes place. Make sure you write a nice full answer here. What else did we talk about? We said about the rising limb. We could say in the first storm hydrograph there is a steeper rising limb. So we have that flashy storm hydrograph, and we said that that could be due to there being steep slopes which increase the rate at which water enters the rivers.
Now we're moving on to fluvial processes, and really these are factors which affect the shape and the flow of rivers, and we'll be looking at things such as erosion, weathering, deposition and transportation, and unfortunately these words do sound quite similar and you do need to know them in lots of detail. So first of all we'll start with erosion, and really this is the wearing away of soil and rock in riverbanks and rivers. Now there are 2 types of erosion, vertical and lateral. So vertical, as the name suggests, involves deepening the river, and this is mainly due to hydraulic action, which we'll talk about lots later. In terms of where you find this sort of erosion, it's mostly in the upper course of the river, so near its source. Lateral erosion, as the name suggests, involves making the river wider, and it involves eroding away at those banks of the river. This is actually more common in the middle and lower courses of the river. So vertical erosion we'll see towards the start of the river, the upper course, that involves making the river deeper. Lateral erosion makes the river wider, and it happens more in the middle and lower courses of the river. Now there are lots of different ways in which erosion may take place. Some of these include hydraulic action, which we've just mentioned, attrition, solution, otherwise known as corrosion, and abrasion. So we'll start with hydraulic action and look at that in a bit more detail. This is really due to the force of the river against the riverbanks. And what happens is there's air that is squashed within cracks and crevices found within those riverbanks, which weakens them and fundamentally leads to their erosion. Hydraulic action, as we've already mentioned, is the main source of vertical erosion, so we know that that river will get deeper as a result of hydraulic action. Next up, abrasion. Now, abrasion can be responsible for both vertical and lateral erosion, so that's making the river deeper and wider. First of all, material carried by the river scrapes away at the riverbank, hence how it makes the river wider. This also loosens material in the riverbank, meaning that that is more easily carried away by the river. Sandpaper action widens and deepens the river, and you also may see that the river gets undercut by rocks rubbing away at the bank. So again, just to mention, abrasion is responsible for both vertical and lateral erosion. Attrition now, another similar sounding word. This time it's rocks being carried by the river, knock against each other and actually cause these rocks to break apart and become smaller. How about solution or corrosion? In this case, the river water itself dissolves minerals in the riverbanks. Also, if the water is weakly acidic, it will dissolve soluble particles. And so this is a lot more gentle, but again, we can see that the river will become wider and deeper as a result of solution/corrosion. So we've dealt with erosion now, but what about weathering? As the name suggests, it's how different types of weather may affect the river's shape and flow. There are three types we are going to look at today: mechanical weathering, biological weathering, and chemical weathering. And there is some overlap with the chemistry specification for some exam boards. So mechanical weathering, the freeze-thaw type of weathering. So what happens here is that water in very cold weather freezes within the cracks of rocks. And when that water freezes, it expands, pushing that crack wider. So you can imagine how lumps of rock will break off those riverbanks. Chemical weathering is all to do with slightly acidic rainwater, dissolving soluble particles, breaking down the rock in a more gentle way. But again, this is still a type of destruction to the riverbank. Biological weathering. Biological always means to do with living organisms. Here it's plant roots which grow in small cracks of the rocks, and as those roots grow bigger, they widen the cracks, causing it to potentially break off bits of rock. Weathering is tightly linked with mass movement, because you can imagine as those small chunks of rocks break off, if this happens in a large quantity, this is what we call mass movement. And particularly if you have a steep slope, which we'll talk about lots later, you'll see a huge movement of material down those riverbanks. There are two types of mass movement. One is soil creep and one is slumping. So slumping occurs when the bottom of a valley slope is worn away by the river flowing. The slope becomes unstable and material slumps down towards the riverbed. This is particularly applicable after heavy rainfall. You can actually imagine how that material will just fall off of the side of the slope after rain, after it becomes unstable. What about soil creep? Unlike slumping, which occurs quite rapidly, soil creep, as the name suggests, is a much slower process. Rather than occurring on steep slopes, you'll see soil creep occur on gentle slopes, where weathered material gathers at the bottom of the slope and then it is eroded further by the river. Now we're going to look more closely at the factors which affect weathering, and remember, mass movement is tightly linked with weathering, because once weathering occurs and small bits of rock break off, that means that they're more susceptible to move as a whole. So what factors affect weathering and mass movement, and do be prepared to explain them? So first of all, weather. Obviously, heavy precipitation, heavy rainfall will increase the likelihood of mass movement taking place. Next up, the slope gradient. So the steeper the slope, the more likely mass movement will take place, and you're looking for slopes above 5 degrees in order for mass movement to take place. Climate now. Hot, wet climates will encourage biological weathering, because these sorts of climates, the heat, that extra water will encourage plants to grow, their roots get in the cracks, widening the cracks, increasing the chance of biological weathering, which therefore increases the chance of mass movement, because we'll have small chunks of rock breaking off. Now vegetation. If you have more vegetation holding down the topsoil, and this has the knock-on effect of decreasing mass movement. Now we consider altitude. So at higher altitudes, you'll find colder temperatures. Colder temperatures are linked with mechanical weathering. So at very cold temperatures, you're more likely to find that water and rocks will freeze, causing that expansion of the cracks, meaning that bits of rock break off. So remember, that's the freeze-thaw weathering. And again, that will increase mass movement. Last up, the geology. So we're really looking at rock type here. Now, very hard rocks such as granite are less prone to weathering, meaning that mass movement is less likely to take place. Limestone, which is a lot more porous, it's very easily affected by acid rain because remember that calcium carbonate dissolves in the slightly acidic rainwater. This is going to break down far more easily. You're going to get small chunks which break off, increasing the chance of mass movement. Transportation now. Transport, that means the movement of substances. So really transportation in a river setting means how material is moved down a river. There are different ways of transportation. One is saltation, one is solution, and the last two are suspension and traction. So always bear in mind, what is the umbrella term? Well, we're talking about transportation. So how does saltation lead to material being moved downstream? Well, you have small sand-sized particles, so very tiny particles which are moved downstream by the river, and that is saltation. Suspension, this is when small particles are held within the water itself and they're just carried naturally downstream. Traction is when the heaviest material that's sunk to the bottom of the riverbed is rolled along the riverbed. And then finally solution, materials are dissolved in the water and then carried along naturally in this way. Deposition. This is the laying down of material transported by a river. Let's try and think about where this is most likely to take place. So where is that material going to be laid down? Well, hopefully it seems fairly straightforward that this would occur most likely where the river speeds are slower to give it time for the material to be deposited, where there's less discharge, so less water flowing through the river at any particular point, and fundamentally where there's less energy. So a good place for this is where the river mouth meets the sea. So what sort of things, we've kind of already mentioned them, but what sort of things affect deposition? So that will be sediment size, it will be the presence of any confluences, it could be any natural barriers or blockages in the river. If there's low rainfall, meaning less discharge, the gradient of the river will affect it. So obviously a shallower gradient will mean less deposition. Now we're going to look at some past paper questions. State one physical factor that influences deposition in a river. So remember, deposition is the laying down of material transported by a river. You have so many options here. You could talk about sediment size, river speed, gradient, the presence of any confluences, if there's a blockage or any kind of barrier, but they only want one factor, so I'm going to go with sediment size. Explain how abrasion erodes the river channel. Abrasion is a type of erosion, so obviously that's going to lead to the river being scraped away, becoming wider and deeper. But we need quite a specific answer here for the 2 marks. So first of all, we're going to start by stating that material carried by the river scrapes away the riverside, creating a wider channel. You could be really specific and talk about sandpaper action, widens and deepens the river. Explain one weathering process in a river valley. So do you prefer the freeze-thaw weathering? Do you prefer talking about biological weathering, which is all to do with roots growing into small cracks, or maybe even chemical weathering, which is acidic rainwater, which breaks down some of the rocks? So it's up to you, but just pick one and explain it properly. I'm going to go with mechanical weathering. So this occurs when water enters cracks in the rocks. The water freezes when it's really cold, and when it freezes and turns into a solid, it expands, which forces the cracks in the rock wider, and sometimes they break off. Now we're going to move on to how the characteristics of a river change in the upper, middle and lower courses. So first of all, let's understand the terms long and cross profile of a river. So the long profile of a river is if you were to take a river from its source to its mouth. And effectively you were to look at how that river changes from the source to its mouth in terms of the things we've just discussed. So shape, river speed, sediment size, discharge, etc. We'd be looking at how those things change from the source to the river mouth. Whereas the cross profile of a river is if you were to basically cut slices into that river. So you'd end up with just a cross section. So that could be near the source, it could be near the mouth, it could be anywhere in between. So we'd be looking at things like the width of the river, the depth of the river, and at a particular point what that sediment size, discharge and river speed is doing. So going into more detail, let's look at the upper course of the river. So near the source, what would we expect to see? Well, we'd expect to see that the river is deep with steep sided V-shaped valleys. You'd expect to see waterfalls, gorges and interlocking spurs. If you've been near the top of a mountain, you'll notice that there's the presence of very large boulders, very little sediment. So that means that river will be nice and clear. And why is there very little sediment? Well, there hasn't really been enough time for erosion to take place. We looked at that in a previous video, all the ways in which that river bank and bed is eroded away, producing those small pieces of sediment, which basically makes the river less clear. Vertical erosion will be largely dominant here, and that, remember, is the deepening of the river. In terms of human use, you might find hydroelectric power, so dams are built with a reservoir behind which it provides a source of energy from those turbines linking to the generator generating electricity. There's often hill sheep farming, forestry, and it's often a good source of tourism, and that's because the upper course is often found in mountainous areas, and mountains make great places for ski slopes and other alpine sports. As we enter the middle course of the river, we'll find that the gradient is shallower, so those slopes will be less steep, and the river is wider. We'll have increased river velocity, partly due to increased water within that river. The sediment shape will be rounded, smaller and smoother, and because some erosion has taken place, you'll find that there's sediment added to the water, so it'll be less clear. Lateral erosion is the dominant type of erosion found in the middle course of the river, and that will lead to things like meanders, oxbow lakes. In terms of land use, you'll often find settlements, farming and industry in the middle course of a river. What about the lower course of a river? So as we approach the sea, the mouth of the river, again you'll find that the river gets wider. That slope will become gentler still. You'll have increased river velocity due to increased water volume, and that could be due to tributaries adding extra water to the river. You'll have the smallest sediment found in this portion of the river, and that's known as alluvium. That often enters suspension, meaning that the river will be even less clear than it was before. So in terms of how that river's clarity and transparency changes, it will be the most clear at the upper course, and then as you go to the middle and lower course, it will become less clear. Again, we'll see lots of lateral erosion evident, which will lead to the formation of oxbow lakes, meanders and floodplains again. So do be prepared to list these characteristics in the various parts of the river. In terms of land use, you'll definitely see lots of settlements, industry and farming in the lower course of the river. If we now summarise the long profile in both the upper and lower course of the river, at the upper course you'll find that the long profile is steep and the river is narrow, whereas in the lower course of the river, the long profile is shallow and the river is wide and deep. Now remember, with this topic, they could give you an Ordnance Survey map with a particular river and ask you to identify various characteristics in the upper, lower and middle course of the river. So these are the sorts of things you want to be looking at. Remember, if the contour lines are close together, that would indicate very steep valley sides. So you'd often find that in the upper course of a river. Make sure you can identify interlocking spurs as well as floodplains. When you see that snaking of the river, remember those would indicate meanders, and you might even notice an oxbow lake. In terms of land use, be prepared to identify towns, which would indicate human settlement. Any industry taking place, remember that will be more common on the middle and lower course of a river. Now we're going to look at the formation of waterfalls, oxbow lakes, levees, river floodplains, etc. So let's start by stating what the physical landforms are of the upper course of the river. Remember, you'd expect to see V-shaped valleys, interlocking spurs, gorges, river rapids, and waterfalls. So starting with V-shaped valleys, how do they form? Well, they form due to vertical erosion, which acts to deepen the river. The river cuts downwards due to hydraulic action and abrasion. The river erodes downwards, you get freeze-thaw weathering, which breaks off pieces of the riverbank and causes soil creep. But what about interlocking spurs? Well, very similar to V-shaped valleys, we're going to have vertical erosion where hydraulic action and abrasion cause that river to deepen. What happens next is the river winds and bends in order to avoid harder rock, and then repeated vertical erosion means that parts of the land stick out in order to form the interlocking spurs. Moving on to waterfalls. So In order for a waterfall to form, you need hard rock above soft rock, which means that that soft rock below will be eroded first. The erosion undercuts the hard rock, meaning that eventually you'll get an overhang, and then through vertical erosion and hydraulic action, you'll find that a plunge pool is created which acts to deepen the waterfall. So we've dealt with the upper course of the river. What about the middle course of the river? Here you're likely to find floodplains, oxbow lakes, and meanders. So remember, meanders are those characteristic S-shaped bends in the river, and they can actually be very distinctive in places like the Amazon. But how do they form? Well, the river flows fastest on the outside of the bend and flows slower on the inside of the bend. So what you find is that on the inner bend, deposition occurs because the river has less energy, so more sediment can be deposited. On the outer bend, more erosion takes place due to hydraulic action. The river erodes and deposits laterally. Remember that meanders and oxbow lakes are very tightly linked, because eventually what happens if erosion is such that effectively the S on the meander gets cut off, then you end up with an oxbow lake. So again, how is an oxbow lake formed? Well, we're going to start by saying that the river flows fastest on the outside of the bend and slowest on the inside of the bend. Again, on the inside of the bend, deposition occurs because the river has less energy and therefore sediment can be deposited. The outer bend, we see erosion due to hydraulic action. Eventually, the bank at the start and the end of the meander will meet, and full flow breakthrough will provide a shorter pathway for the river, and then the oxbow lake forms due to deposition on the new riverbanks. Now, a floodplain is the area of land directly adjacent to a river, and it's found in both the middle and lower courses of a river. A floodplain forms when river discharge is high and the river overflows its banks. Now, that river water may infiltrate the soil, leaving behind a layer of material which builds up to form the floodplain. Moving on to the lower course of the river, so what physical features do we find here? Well, first of all, we find that floodplain. So again, be prepared to describe how that floodplain is formed due to the high river discharge, meaning that the river overflows its banks. Alluvium is deposited. You'll also find levees, the river mouth, deltas, and potentially islands. Well, what is a levee? Well, it's natural embankments that form by the banks of the river. How are levees formed? They're created by deposition. So when the river flows over its floodplain, the velocity of the river slows. This means that the river is unable to hold all of the sediment contained within it, meaning that the sediment is deposited. What actually happens is the largest sediment is deposited first, and then the smallest sediment is deposited furthest away from the river, and this is a process known as sorting. And as you might expect, this process repeats over time, meaning that eventually you get these natural embankments known as levees. Now let's look at some past paper questions.
Explain the formation of a river meander. So we'll start by talking about how fast the river's flowing on both the outside and inside bend. Remember that the river flows fastest on the outside bend. And then make the full comparison, and slowest on the inside bend. Because of this, on the inner bend, deposition occurs due to there being more friction here. On the outer bend, erosion occurs due to hydraulic action. Now we're being asked to explain the formation of a waterfall. Remember, a waterfall can only occur where there's a band of hard rock sitting above softer rock. Remember that softer rock will erode first. And over time, this creates an overhang. Which collapses as it's unsupported.
Moving on to uses of water and why there's shortages and surpluses around the world. She looks so long. Hi everyone. If you've been following my science videos for a while, you know about Lyra, but here she is in geography because she's going to help me with my water quality video. So broadly speaking, what factors will affect water quality? We can divide them into agricultural ones, industrial ones, general human activity, deforestation, which means cutting down trees, and then we'll be looking more at water treatment, both how it can improve water quality but also reduce it if not carefully managed. Now, to do well in your exam, you'll need to provide lots of very detailed answers, so we're going to take each of those categories in turn. So first of all, how can agricultural and farming practices reduce water quality? Well, first of all, liquid slurry, so that's effectively animal feces, animal poo, can wash into rivers and they'll cause a phenomenon known as eutrophication, meaning that the rivers become very lacking in oxygen and all the aquatic organisms die. But in this way, water quality is hugely affected. Next up, with agriculture, remember fertilizers are added to soil to improve the fertility of the soil. These can also be washed into the rivers and the groundwater, making it hugely contaminated. These are not things as humans we want to be consuming in our drinking water. And last up, deforestation is a common agricultural practice. Sorry, there's a dog barking. Now, the reason why farmers deforest, why they cut down trees, is to provide more space to grow crops and more space to rear their livestock. Now, what happens when you cut down trees is that you have fewer tree roots to hold down the topsoil, so you get surface runoff, meaning that more soil and silt flows into the river, reducing the water quality. Now we're looking specifically at how human activity can alter water quality. Now, obviously homes are full of toilets, which if the raw sewage from those toilets is allowed to flow directly into the river, you'll really reduce the water quality because of the huge increase in bacteria in that water. The same is true if you have leakages from sewage treatment plants, so places where that water is treated to make it safe for human consumption. If those sewage treatment plants aren't carefully managed, then you can get massive leakage, which will adversely affect the water quality of surrounding rivers. Another way in which water quality is reduced, which you might not initially think of, is the emptying of chlorinated swimming pools. Remember that swimming pools have chlorine added to them in order to kill any bacteria present and to make them safe for our use. Emptying this chlorinated water into our rivers obviously has a really detrimental impact on the water quality and will affect all the aquatic organisms that live there. The only good thing really that humans do to improve the quality is through those sewage treatment works. If carefully managed and properly cared for, they will obviously remove all that solid waste, remove all the bacteria, and really the effluent from that sewage treatment centre should be really clean water. So therefore, in that way, the water quality is improved. Next up, how can industry affect water quality? Well, lots of factories use cooling systems and they use water in order to cool down their machinery. Now, the output of those cooling systems is much higher temperature water, which gets emptied into rivers, killing many organisms found there and generally upsetting the river ecosystems. I'm sure you've seen lots of pictures in the news when oil refinery spillages take place. This is an awful episode because what happens is all the oil floods into the rivers, into the seas, causing all those poor seabirds to get stuck and widespread death to these organisms. And then the last industrial process I want to talk about is the iron refineries. So this is places where iron ore gets processed in order to make pure iron that can be used in building bridges, settlements, etc. Now you get some really toxic chemicals getting washed out of these processing plants into rivers, and you'll see the whole river turn red. Just as a quick aside, remember the term potable water is just water which is fit for human consumption. So what are the three main stages in managing the supply of clean water? Well, number 1, collection, number 2, treatment, and number 3, delivery to the end user. Where is this fresh water collected from? We talked about this in a previous video. Reservoirs, lakes and rivers, aquifers and wells. Once we've got that water from these various sources, how is it treated? Well, we briefly mentioned at a sewage treatment plant or at a water treatment plant. So the first step is filtration. That removes any solid bits that have entered the water. That could be as basic as stones or twigs. Then you have sedimentation, which removes suspended particles, so little pieces of sediment that make the water cloudy. And then the final step is chlorination, the adding of chlorine in order to kill any bacteria present to make that water safe for drinking. That water is delivered to end users quite often along pipelines, although in less developed countries you'll often find a standpipe where people collect the water in bottles and buckets. So how is the water supply managed? Well, if we look at reservoirs and dams, remember a reservoir is an artificial storage place of water and it often has a dam to hold that water back. Now, that water will be allowed to flow onto the pipelines which supply the houses as and when it is needed, so that can be very carefully managed. Dirty or used water from homes is taken to sewage treatment plants where it goes through those treatments we've just discussed, and then it's piped back to people's homes. Desalination, as the name suggests, involves the removal of salt. So sometimes in some countries, such as in the Middle East, they'll need to get their drinking water from seawater. That seawater contains an awful lot of salt which needs to be removed, and that is the role of the desalination plant. Now we're going to be talking a lot more in detail about the use of dams in managing the demand and supply of water. As I've already said, dams are used to hold back waters in reservoirs, and through careful management that water is allowed to run along pipelines to people's homes. The other great thing about dams is it can be used for hydroelectric power, which remember is a renewable source of energy. When that water is let out of the dams, it turns a turbine, which is like a giant windmill, which turns the generator that can be used to power people's homes through the electricity it produces. So hydroelectric power is a fantastic byproduct of the building of a dam. And for this reason, you find lots of dams. So in Africa, for example, there's over 600 dams, and in Europe, as many as 1,200. The fact that that water is held behind the dam and the reservoir helps to prevent flooding further downstream, and it also enables water to be held back for periods of time when water levels are naturally lower and there is a drought. And this can therefore reduce water insecurity. Now, the Great Renaissance Dam has had a huge amount of controversy attached to it. So the people in Egypt are concerned because they have a reduced control of that water, and that water is so important for so many of their livelihoods, so they may end up suffering from water drought. And then the people in Sudan are concerned because when that water is released from the Great Renaissance Dam, it might overwhelm smaller dams and rivers which have smaller capacity. And it's really that ability of dams to control water where rivers cross international boundaries means that there are potential issues created as to who controls the water supply. Now let's look at some past paper questions. Study Figure 1A in the resource booklet. Explain 2 ways human activity can affect water quality. So here's Figure 1A, and let's try and zoom in on some things which will affect the water quality. So this sewage treatment plant down here is a good thing, remember, because it processes the sewage and ensures that that water gets purified. It gets all those horrible microorganisms removed so it's suitable for household use. The same with the water treatment up here. That will be improving the quality of the water in the dam. In terms of reducing the water quality, this house obviously is going to be producing lots of raw sewage from that toilet right there. It even says raw sewage out. So if that gets untreated, that will cause eutrophication as it enters the river. And again, we've obviously talked about the sewage treatment plant as being a good thing, but again, if there are leaks, we're going to see eutrophication taking place down here as well. We're going to start by talking about the discharge of untreated sewage from houses. Then we'll talk about it from a positive perspective. So water treatment facilities can process the water to ensure there is a higher amount of water suitable for household use. Explain 1 way agriculture can affect water quality. I've already touched on it before. We could talk about eutrophication. We could talk about anything to do with deforestation. Remember, that's cutting down trees to provide more space to grow crops or for livestock. If we were to talk about livestock, we could potentially talk about cattle waste, and that leaching into the rivers, again contaminating the water, as that will increase the bacterial load. Lots and lots of options here. I'm going to talk about the eutrophication answer. So liquid slurry, that's really the feces from cattle, can leach into the river, so wash into the river. And because of all those extra nitrates that it contains, it causes the algal bloom, which is eutrophication. And the knock-on result, remember, is that you end up with the river being starved of oxygen, so all the aquatic organisms die.
First of all, why is flooding such a problem? Well, flooding causes damages to people's home, general infrastructure, people's businesses, their factories, as well as communications. You coming? Come on. Look, she loves me really. So what physical factors affect flooding? So level of precipitation or rainfall, the density of the river network as well as its gradient. If there's any existing saturation of the soil from previous flood events, that will increase the likelihood of flooding. The time of year and any seasonal changes. So when there's been a lot of snowfall and then the temperature increases, you'll get a snow melt, which will increase the chance of flooding due to an increase in the river's discharge, and steepness of slopes, so the relief of the land. The steeper the slope, the increased chance of runoff and increased chance of flooding. What human factors affect the risk of flooding? Well, firstly, the population distribution and density, various land use, flood management strategies. So if you've got hard engineering structures in place, such as flood walls, that will decrease the chance of flooding. Embankments, allowing salt marsh regeneration. Again, this will reduce the chance of flooding, and we'll look at this in great detail in another video. When you've got increased urbanization, so people building houses, you're going to have increased surface runoff, because firstly, you'll have less interception by vegetation, quite simply because that vegetation has been removed in order to create more land to build settlements. Because building settlements involves an awful lot of concreting, paving, putting down roads, again you'll see increased surface runoff here, and this increases the chance of flash floods. If you're asked for quite a long answer, an exam question with like 8 marks, asking you to analyse the reasons why different areas are differently susceptible to flood risk, we're going to look at both a combination of physical and human factors. So we want to be looking at, whether urbanisation has taken place, if deforestation has occurred, increased concreting and paving, which leads to increased surface runoff, leading to more flashy river regimes, meaning increased flood risk. We want to look at the presence of any flood management strategies, so that's seawalls, salt marshes, managed retreats, etc. Any changes to weather or time of year, so as we said, increased snow melt or increased precipitation. What about the relief of the land? So these are all factors you want to be looking at in that resource booklet, because obviously the case study will vary from year to year. They could ask you in slightly different ways, but these are the sorts of things you want to be looking at. Now we're going to be looking at flood prevention strategies. So broadly speaking, that will be divided into hard engineering and soft engineering strategies. Hard engineering strategies involves building artificial structures which try to control the rivers and help prevent flooding in this way, such as the building of seawalls. The hard engineering strategies tend to be more expensive and they need an awful lot of maintenance. Soft engineering strategies do not involve the building of artificial structures. They take a more sustainable and natural approach to preventing river flooding. That could involve encouraging wetland development. I'm now going to describe the various hard and soft engineering strategies in much more detail. So starting with hard engineering strategies, we'll be looking at the relative advantages and disadvantages. So starting with dams and reservoirs. Now the good thing about these is that water can be controlled, and also it provides a good source of renewable energy in the form of HEP, hydroelectric power. But the problem with dams and reservoirs is they are very expensive, and I have touched on this previously. Where rivers cross international boundaries, you're going to have a lot of conflict in terms of who's controlling that water supply, and it could lead to a great deal of water insecurity for countries which are downstream of those dams. The building of such dams and reservoirs also leads to a huge amount of damage to ecosystems and loss of biodiversity as deforestation occurs. Flood embankments and seawalls hold back the flood water and prevent damage to farmland and settlements. They are very expensive, and again, they will adversely affect ecosystems and lead to deforestation. There is the potential to increase the height of the seawalls as sea levels change, and clearly these will save lives, help prevent damage to settlements, and they are a very effective way of preventing flooding. Although at the beginning there's just a one-off cost, they will need maintenance because in 100 years, for example, these seawalls will probably have been breached and therefore they'll need to be rebuilt. The next hard engineering strategy I want to talk about is river straightening and river dredging. So straightening the river increases the speed of the river, meaning that it can effectively hold more water, which is good when you see increased river discharge, which may lead to flash floods. And dredging means removing lots of sediment, any waste that's entered the river, again meaning that the river can hold more water. So through straightening and dredging, we'll see the river can hold more water, therefore helping to prevent floods, meaning that less damage occurs to people's homes, and it means that people's lives are less at risk. In terms of disadvantages, that river dredging does need to be done fairly frequently, so there's a cost incurred with that. And river straightening, because that increases the speed of the river, it may actually increase flood risk further downstream. Turning our attention to flood relief channels, this is when river water flows into smaller channels where it can re-enter the river further downstream. By removing this excess water, it reduces the chance of flooding and all the disadvantages that come with that. However, this approach is quite expensive to build, and if water levels continue to rise, then these river channels may also flood. Moving on to soft engineering approaches, this includes flood warnings and preparation, flood control schemes, and floodplain zoning. So flood warnings and preparation, in this case the environmental agency monitors rainfall, looks at the chance of floods and issues warnings either across the TV or radio, telling people when floods are most likely to occur so people can be warned and leave if needs be or put any necessary precautions in place. This could simply mean using sandbags to protect their properties, meaning that their possessions are saved and fewer insurance claims are made. There are quite a few disadvantages with this approach, however. Firstly, those flood warnings may not occur quickly enough, people may not hear them. Secondly, it doesn't actually stop any of the flooding. So although people's lives will definitely be saved, if the flooding is such that people's homes still get damaged, then obviously this isn't a sufficient method. Floodplain zoning involves using floodplains for very particular land uses and therefore restricting the building of houses and factories in these areas which are more susceptible to flooding. So more expensive buildings are built further away from the river in areas less likely to flood. And this obviously reduces damages to these types of buildings. But remember, it's not always possible to change existing land uses and people will still be inclined to build there and buy their homes there. So it's very important that you check whether your house that you're planning on buying is built on a place that's likely to flood, because in that case it should be avoided at all costs. Flood control schemes encourages the development of wetlands and marshes because these act as great temporary stores of water. They're a very natural and sustainable approach and encourage wide biodiversity, increased speciation. It's nice and cheap, but as with all things, it's not always possible. I think it's because it's cold. Please don't. You're gonna tear a hole in my leggings. She's growling because she hates it when she's moved, but I can't just sit in front of the camera all day. You can find you a warm place to sit, you know. Study figure 1A in the resource booklet. Explain one advantage and one disadvantage of the flood prevention measures shown. So we have details about flood prevention measure in York in the UK, so have a look at what we have here. Definitely use the key look. We have flood walls and gates, and we have a flood embankment. So what's good about the flood walls? Well, obviously they're going to reduce the level of damage caused by the floods, which could save people's lives, particularly in the people living around Earlsborough Terrace. Real disadvantages with flood walls, though, remember these are hard engineering strategies. They're very expensive because of the huge amount of work that goes into removing those trees, which they've already mentioned here. To build new flood defences, 14 trees must be removed. So from an environmental point of view, that's terrible because that destroys habitats for wildlife. And it's something that will need maintaining. So for an example, in 100 years, it's unlikely those flood walls will still be here. So we're going to start with the advantage, which is that flood walls reduce the level of damage
caused by floods, potentially saving lives. Disadvantage: trees need removing to allow flood walls to be built. This destroys ecosystems and animal habitats.
Now we move on to wave action. So starting with the term fetch, this is the length of water the wind blows over. If we consider the factors which influence the size of the waves, first of all, the strength of the wind. The stronger the wind, the bigger the wave. The time frame that wind is blowing over. The longer the wind blows for, the bigger the wave. And then lastly, the fetch size, because obviously the longer the length of water that wind blows over, the bigger the waves formed. The prevailing wind is the dominant direction the wind is blowing across. So in England, the southwest coast prevailing wind comes from a southwest direction, which means it blows over the length of the Atlantic Ocean. So how do those waves form? Out at sea, the wind tugs at the surface of the water, causing the wave shape to move. Within a wave, water moves in a circular motion. When a wave moves into shallower water, friction causes the waves to slow at the base, and then friction causes the wave to break at the top because the wave is travelling faster here. And then as waves break onto the shore, this is known as a swash. The beach will absorb the energy of the wave and then the water will drain back to sea, and this is known as the backwash. There are two types of wave you need to know about, both constructive and destructive. Now, first of all, a constructive wave has a long wavelength, a strong swash and a weak backwash, and this helps to build up a beach. Constructive waves can reduce the gradient of a beach because they have such a strong swash and a weak backwash, therefore material gets deposited on the beach, therefore reducing its gradient. In comparison, a destructive wave has a short wavelength, a strong backwash and a weak swash, and as you can imagine, that will cause beach material to be moved back down to the sea, and fundamentally a destructive wave will erode a beach. Let's move on to coastal weathering. What is weathering? It's the breakdown of rocks in situ or close to the Earth's surface. There's several different types you need to know about: mechanical, chemical and biological. Mechanical weathering is the physical breakdown of rocks due to the environment. There's several different types. The one you're probably most familiar with is the freeze-thaw model of weathering. So what happens is that water gets into cracks, and then as the temperatures drop, the water freezes. The frozen water expands, causing cracks in the rock to become wider and chunks of rock break off. There's also onion skin weathering. This is when the outer layer of the rock peels off due to extreme variations in temperature. The wetting and drying model of weathering is most commonly found in coasts where there's an awful lot of clay. So what happens when the clay is wet is that it expands. When it's dry, it contracts. And this kind of frequent expanding and contracting enlarges cracks in the rock and makes them more susceptible to other weathering types such as freeze-thaw. Next up, what is mass movement? Mass movement is the downward movement of sediment due to gravity, and there's lots of different types of mass movement, starting with rockfall. As the name suggests, this is when bits of rock fall off the cliff, often due to freeze-thaw weathering. Then you have mudslides. Mudslides involve saturated soil, so soil which is filled with water sliding down the slope. Landslides is when large chunks of rock slide downhill. Slumping is when a whole segment of cliff moves downslope along a saturated shear plane. Rotational slip is when saturated soil slumps down a curved surface. Now we're going to talk about coastal erosion, transportation and deposition. Now there's a lot of different erosion types you need to be aware of. We'll be looking at hydraulic action, abrasion, attrition and corrosion, otherwise known as solution. So starting with abrasion, this is when broken fragments of rock are hurled against the cliff by wave action, causing bits of rock to be eroded off the face of the cliff in a sandpaper-like action. Hydraulic action is when waves hit the cliff and water and air goes into cracks. As the water retreats, the air expands, causing those cracks to enlarge. Corrosional solution is the chemical action of the waves on the rock. Because that seawater contains salt, The salt slowly erodes the cliff and the material is carried away in waves. Attrition is when particles carried by the waves crash against each other and get smaller through wave action. In this way, the particles become smaller and rounder. So that's everything you need on erosion, but what about deposition? Deposition is when the waves crash against the beach and the seawater loses energy. This leads to the depositing of particles, sediment, pebbles, sand, etc. In order for deposition to take place, you need to have a stronger swash compared with backwash, because otherwise the backwash will remove all that material back to sea. Transportation is the movement of material by the sea and along the coast by waves.
So traction involves large pebbles and boulders are rolled along the seabed. Saltation involves small stones and pebbles are bounced along the seabed. Gosh, these all sound very similar. Solution is the transport of dissolved rock. And now we're going to talk more about longshore drift.
So what is longshore drift? Well, if we were to define it, we'd say it's the transportation of sediments along the coast in a zigzag-like pattern. But how does longshore drift come about? Because obviously it doesn't happen at every single coastline. Well, first of all, you need the prevailing, so that's the dominant wind blowing at an angle to the coast. Because the prevailing wind is at an angle, the waves swash deposits material at an angle on the beach. And then if you think about which direction the backwash will be happening in, it'll be occurring perpendicular to the beach due to the action of gravity. So whereas that material is being deposited at an angle, in terms of the backwash, it will be occurring perpendicular, so in a straight line, hence you can see that zigzag pattern building up.
What sort of factors will affect coastal environments? Please, Lyra. First of all, rock type. The harder the rock, the less erosion that takes place, so the higher the cliffs formed. The type of rock will also influence the amount of weathering that can take place, whether that's freeze-thaw weathering, biological weathering, and as a result, the type of erosional processes that occur, so whether caves are formed, headlands, stacks, stumps, etc. Human activity will also have a huge role to play. Humans will often choose to build settlements in low-lying coastline, as well as more tourism and leisure-based activities, which are commonly found in very beautiful parts of the coast. Humans may also employ soft and hard engineering strategies, which will cause massive changes to the coastline. Hard engineering strategies include things like groins and seawalls, which help prevent erosion. Soft engineering strategies include the replenishment of beaches. If there's a huge number of fish in the sea, fishing practices will become important. Any fishing boats going out, if there are oil spills, or even larger ships, they'll have an adverse effect on the environment, particularly coral reef ecosystems. Rising sea levels will influence coastal landforms because obviously with the burning of fossil fuels, so the increase in the amount of CO2 being released as well as methane from farming cows, this will all lead to polar ice caps melting, rising sea levels, and that may lead to flooding of low-lying land. Vegetation may also influence coastal landforms. So we tend to think of vegetation as a good thing because the roots stabilise the slopes, but equally with increased number of roots comes an increased chance of biological weathering, because remember, those roots get into cracks in the rocks, they expand the cracks and mean that some of that rock may break off and fall. Hi everyone, I'm now moving on to the role of erosional processes in the formation of landforms. So basically what this video is about is how do headlands, cliffs, wave-cut platforms, stacks, arches, caves, stumps all form. I hope I remembered all of those. So let's start with a headland. Well, a headland forms where you have discordant coastline. You need layers of soft and hard rock which run at right angles to the sea. That soft rock erodes first due to both hydraulic action and abrasion, and then you get the formation of that headland together with a bay. But what about a wave-cut platform? Well, as the name suggests, you're going to end up with a notch at the base of a cliff. So the waves pound the cliff between the low water mark and the high water mark, creating a notch. Now, hydraulic action and abrasion will deepen that notch, so you end up with this kind of overhang. That overhang is unsupported, so it eventually collapses producing a huge amount of debris on the base of the cliff, and through the action of the waves, that will remove that debris over time, meaning that the cliff will retreat. And at low tide, you'll see that wave cut platform being exposed as that water retreats. Now, the cliff is further altered in its shape by the action of weathering. That could be mechanical weathering, so freeze-thaw weathering, where water gets into cracks in the cliff, freezes, expands, causing chunks of that rock to break off. It could be chemical weathering, so that's really the action of acid rain. Biological weathering is when those plant roots get into cracks and they cause those cracks to widen, and again, those rock bits will fall off, further eroding the cliff. So the ways in which a wave cut platform and cliffs are produced are very tightly linked. Now let's talk about the formation of caves. So first of all, let's think about the headlands. Now the headland receives an awful lot of the wave's energy because of the way in which that headland juts out to sea. So the wave pounds away with hydraulic action, abrasion due to any pebbles and rocks being carried by the waves, and that attacks any cracks in the headland. So eventually those cracks widen and deepen, forming a cave. Now when that eventually breaks through, that's when an arch is formed. So that's when you can see the light all the way through that cave. So you'll create this huge arch. Now the roof of that arch is unsupported. So eventually it collapses, forming a long pillar of rock known as a stack. And as that further erodes, a stump will be formed. Now I'm going to describe how various depositional landforms are formed. So starting with beach formation. So in order to build up a beach, you need low, long constructive waves because they have a strong swash and a weak backwash. This means that sediment gets deposited on the beach but isn't actually washed away afterwards. Moving on to a spit. Now, hiya, you're never here. Now we'll move on to how a spit is formed. So in order for a spit to be formed, you need sediment to be moved along the coastline by longshore drift in the direction of a strong prevailing wind. That sediment gets deposited if there are low, long constructive waves, because remember, they have a strong swash and a weak backwash. Now, as the coastline changes direction, the sediment continues to be deposited. So that's how a spit forms. Now, if that spit joins a headland, we form what's known as a sandbar. And then if there's a small river running behind that sandbar, you get a lagoon. And Slapton Ley in Devon is a good example of a lagoon behind a sandbar. Distributions and features of coral reef ecosystems and mangroves. We'll start with coral reef ecosystems. So what is commonly found? What are the features of coral reef ecosystems? Well, they're made up of things called coral polyps, which don't worry too much about whether you know that word, but it kind of doesn't make sense without it. But the point about coral polyps is that they're tiny animals which contain algae, which is a type of plant. They make calcium carbonate. So that's a feature that you'll need to provide in the exam, that coral reef ecosystems contain a lot of calcium carbonate, that's limestone, and that's actually what makes them so hard. Commonly found in coral reefs is high levels of biodiversity, so that's the variety of animals and plants found there, and that they're home to lots of small fish. So if you've seen Finding Nemo, clownfish for example. Moving on to what factors that affect the distribution of coral reefs. Number one, you need a very specific temperature range. So you need a minimum of 18 degrees Celsius in order for that coral reef to survive. The optimum temperature is actually 25. It's worth learning that number. In terms of water depth, you need quite shallow seas, so less than 25 meters deep. And why is that? Because it allows sunlight to penetrate. And it's that sunlight that the algae use in their photosynthesis. In terms of pH, and this is why global warming is such a concern, because it's actually reducing the pH of the seas, corals require quite an alkaline pH, so a pH of between 8 and 8.5 to grow. We need salinity, so that means salty water, i.e. seas and oceans. So if we were looking at positive factors which affect the distribution of coral reefs, what do they need? This is a specific temperature, water depth, pH, salinity. But what are the adverse effects which will actually reduce the distribution of coral reef ecosystems? Well, as you might expect, it's human behaviours. So human behaviours that damage coral reefs and limit their distribution. I've already touched on one. Burning fossil fuels leads to global warming. Sea levels rise. Coral bleaching takes place. That's when all those polyps are released and effectively the coral reef dies, and then just general damage by tourist activity or pollution. So what are the features of mangrove ecosystems? Well, first of all, you'll find that they are trees which effectively have 1 foot in the sea, 1 foot on land. So they're trees which live on the coastline. You'll find shallow water there, which will definitely influence their distribution. So that shallow water needs to be between 0.5 and 2.5 meters deep. You have very characteristic tangled roots, and they grow above ground to form things called thickets. The roots are extremely characteristic of mangroves. You'll also have snorkel-like roots that stick into the air and buttress-style roots which provide support. Also common to mangroves are high humidity and high temperatures, and I'll talk about those exact values when we look at the distribution of mangroves. So what factors affect the distribution of mangrove ecosystems? Firstly, rainfall. Mangroves require a high level of rainfall. That's anywhere between 1,500 and 3,000 millimetres per year. They need a high temperature, otherwise the mangrove trees won't grow. In terms of water depth, again, we need shallow water between 0.5 to 2.5 metres deep. Obviously, the low and high tide will affect that, and they can survive the ranges, but on the whole, 0.5 to 2.5 metres. They need high levels of humidity, between 75% and 80% humidity. So it's making it quite an unpleasant place for us to visit, really, if you think about this. Lots of rain, high humidity. And like the coral reef ecosystem, mangroves require salinity, so salty water. As with coral reef ecosystems, human behaviour can affect the distribution of mangroves. So that includes deforestation, so cutting down of those mangrove trees, and humans use that for timber and building material. You also find that mangroves are commonly removed in order to make space for aquaculture, such as shrimp farming. You find that overfishing causes damage to mangroves. and application of pesticides on farmland may wash into mangroves, causing further damage. Features and distribution of sand dunes and salt marshes. So starting with sand dunes. So what are the features of sand dunes? Well, you'd expect them to be made from blown in sand. Marram grass is a special type of vegetation, very common to sand dunes. They have an undulating shape. Think about the Sahara Desert, how much those sand dunes go up and down, and they're fragile. So they are easily eroded, particularly by high winds. What factors affect the distribution of sand dunes? First up, a wide beach with large quantities of sand is needed in order for a sand dune to form. So the prevailing wind needs to be onshore. That means blowing from the sea to the shore. And that's kind of obvious if you think about the fact that that sand needs to build up on the beach, and you need suitable locations for the sand to build up. So how does the sand dune build up? First up, you need the beach to dry out at low tide. There's that all-important onshore prevailing wind again. And that causes the sand to build up, commonly around obstacles. You will get over time the sand accumulating, leading to the sand dune building up in size. You get lots of mini sand dunes building up because they get protection from the original sand dune. So another sand dune builds up on the seaward side, so facing the sea. And then vegetation such as the marram grass, the roots of that grass will help fix down the sand. Now, sand dunes are quite extreme places for this vegetation. So sand dune vegetation needs to be able to cope with some quite extreme conditions, including salty conditions, so salinity, a lack of moisture due to the sand dune drying out quickly, high winds, and the fact that the vegetation is often submerged by the wind-blown sand. So marram grass is extremely specialised to be able to cope with these tough conditions. Moving on to salt marshes. A salt marsh is an area of coast that is flooded and drained by salt water, which has been brought in by the tides. And the salt marsh forms behind a spit when water movement slows down, so more material is deposited. In terms of their distribution, Salt marsh formation is encouraged in places where there is protection from wind. You need partly salty water, and you need water regularly flooded by tides. A large expanse of mudflat is also required. So to really point out the features of a salt marsh, quite repetitive, but you need that large expanse of mudflat, slow moving water, salt tolerant vegetation, plants, which may include grasses, reeds and rushes. There's often peat, which comprises of decomposing vegetation. Partly salty water, and water regularly flooded by tide. And remember, salt marshes provide a really nice ecosystem for a lot of birds. Now we're considering abiotic and biotic factors that affect coastal ecosystems. Biotic, remember the word biology, they're tightly linked. So that means living factors, which affect coastal ecosystems. Whereas abiotic factors are non-living factors. And we'll talk about examples now. So living factors include marine plants, e.g. seaweed, marine animals, such as seagulls, and even microscopic organisms like zooplankton. Non-living factors include climate, and you can be really specific there. You can talk about temperature, soil pH, rainfall, wind levels. It could be salinity, so salt water, rock type, any minerals or nutrients present. So you can absolutely see this division between biotic, living and non-living factors, which are abiotic factors. Be prepared to talk about specific coastal ecosystems. So for example, if they ask about sand dunes, your living factors would include that marram grass. It could include any organisms which cause disease to that marram grass. It could include animals burrowing inside the sand dune. The non-living factors would definitely include climate, so temperature, soil, pH, rainfall, wind. Now we're considering how coastal ecosystems are threatened by people and their activities. So what human activities affect coastal ecosystems? Well, to briefly summarize, they can be subdivided into industrial activities, agricultural ones, so ones relating to farming, tourism activities, so people going on holiday, as well as deforestation, so that means cutting down vegetation and trees. So let's take each of these in turn. So number one, industry. Dumping of industrial waste into the sea causes water pollution. Which can affect biodiversity and disrupt food chains. Remember, biodiversity relates to the variety of living organisms, whether that's plant or animals within a particular ecosystem. So obviously there's dumping of industrial waste will reduce biodiversity. You also got issues with the need to protect industry against coastal erosion, meaning that you build hard engineering strategies such as sea walls, and that absolutely can damage the natural habitat. Building ports and land reclamation for coastal development can lead to the destruction of coastal environments, reducing biodiversity. So, from an industrial point of view, remember, people build ports, which contain ships, cargo ships, in order to move products around. Land reclamation is all about draining land of sea, meaning that you can then build on it, and clearly both of these things are going to destroy coastal environments and reduce biodiversity. Now we're going to move away from industry and consider tourism. So the first thing mass tourism can do is increase the levels of pollution on the beach. And that pollution, those polluting materials can enter the food chain and therefore endanger marine populations. The tourism industry may lead to tourists scaring wildlife, which obviously has a negative impact on the coastal ecosystem. Let's now consider deforestation. And really, when we talk about coastal ecosystems, we're kind of talking about the trampling of vegetation. So that's when people walk around on sand dunes, for example. And sand dunes are very fragile. And if you damage those marram grasses, you're going to have fewer roots to hold down the sand which the dunes are comprised of. And then lastly, agriculture, so farming. Now, farming often uses chemical fertilizers. Now, remember, when it rains, these may be leached, washed into the sea or onto salt marshes. Make sure your answer is relevant to the exact question being asked. I'm just going to write leached into water, which leads to eutrophication. So that's the buildup of algae. When the algae dies, bacterial numbers increase, using up all the oxygen, making that water very lacking in oxygen, therefore reducing aquatic life. So that's going to damage the ecosystem. Agriculture also involves the applying of pesticides. So these are chemicals which kill pests, like aphids. Now these are very toxic and they disrupt food chains. And if they build up in those food chains, two good words to use are biomagnification and bioaccumulation. Remember, with agriculture, you'll often find land reclamation just to provide more land for farming. So we can steal this answer here. So land reclamation for farming use leads to the destruction of coastal environments and therefore reduces biodiversity. So broadly speaking, this upload is about conflicts between different users of the coastal ecosystems. We're going to start by considering what goods are provided by coastal ecosystems. So obviously human food, from fishing, using lobster pots to obtain shellfish. We get animal feed from fish meal. Obviously, seawater is incredibly salty, so we can obtain that salt, and that helps us preserve food. And particularly in the olden days, this was the main way in which people preserve their food. And then lastly, we get land, which can provide space to build settlements and farming. We also get construction material, particularly sand, which we can harvest from our beaches, and we need that sand for making concrete, cement, mortar, which we stick our bricks together on our houses. What services now are provided by coastal ecosystems? Well, when we build harbours, we get protection from storms. Leisure pursuits, such as scuba diving, snorkeling, sunbathing on beaches. Remember, most coastal ecosystems, but particularly coral reefs, salt marshes, are a great source of biodiversity and provide great habitats for wildlife. Who are the main users of coastal ecosystems? Well, local residents who live there. Other users include employers, as we have places for shops, offices and factories. Places for farmers, if that land has been reclaimed, they can plant crops or keep their animals there. Any harbours and ports provide work for fishermen. Now the transport industry will build ports and airports close to the coast for obvious reasons. Particularly those ports will allow the movement of shipping containers. And then finally tourists, which is probably the one which you'll think of first of all, which will be using the beaches and hotels which have been built there. Now really looking at potential conflicts. So potential conflicts over use of coral reef ecosystems. So if we consider tourist use, they want to go snorkeling and scuba diving to look at the wide range of biodiversity. Then you've got fishing men, which will want to fish on the coral reefs, reducing biodiversity, causing potential damage. So a major source of conflict here is going to obviously be the conservationists will want to preserve the coral reef, which is likely to conflict with the interests of the tourists and the fishermen who want to use it as a resource. Now we'll consider conflicts and mangroves. Remember, mangroves provide a great place for fish and crustacean nurseries, so where they are going to spawn and bring up their young. Those mangrove roots trap silt and help create new land. Mangrove timber provides a source of fuel and building material. So we can already see a potential conflict here between the preservation, where we want to maintain our mangroves to provide fish and crustacean nurseries for those mangrove roots to hold down the silt. But then obviously if we have humans wanting to deforest, to harvest those trees for timber, that's obviously going to cause damage. So there's a conflict between preservation and destruction of mangroves. And we'll really talk about what those types of destruction are. I've already mentioned deforestation, land reclamation, and even aquaculture, which is the farming of fish and shrimps. So the roots hold down silt, and the mangroves provide protection for low-lying land against storm surges. Now we take sand dune and potential conflicts. These are likely to be the least threatened because they offer little by way of leisure tourism, industry and agricultural possibility. So least under threat. There's one way in which they could be used for leisure activity. People like to build golf courses and they like to go trekking and horse riding because they are very pretty, and obviously that can destroy that fragile sand and marram grass. And we do really want to protect our sand dunes because, again, they provide protection for low-lying land against storm surges. Moving on to causes of coastal flooding. And we're going to be looking at storm surges, tsunamis, and climate change. Starting with storm surges. What is a storm surge? Well, it's a temporary rise in local sea level produced when a storm reaches a coast. In terms of the optimum conditions for a storm surge, it's a combination of high tides and low-lying land. And a place where this commonly happens is the Bay of Bengal. What about tsunamis? So how are tsunamis caused? They're caused by earthquakes which occur at destructive plate boundaries. And then in more detail, an oceanic plate is subducted, so forced under a continental plate. And it's this movement which thrusts the water above, causing the huge characteristic tsunami wave. And as we know, these waves can travel enormous distances. What happens when the waves reach shallower water is, first of all, the shallower water causes the slowing of the waves. You might know this from physics. When waves slow down, they move closer together. It's a bit like traffic on a motorway. The slower the traffic, the closer the cars are. The height of the wave may increase by several meters. And then the water retreats, and this indicates that the tsunami is approaching the coast. And then you get the huge waves which are characteristic of the tsunami. Lastly, how does climate change cause coastal flooding? Well, it's the release of greenhouse gases such as carbon dioxide, methane. The enhanced greenhouse effect causes global warming, and that melts polar ice caps. Then you get a rise in sea level, which will obviously flood low-lying land and coastal areas. So you'll probably know this from biology as well. Strategies used to predict when flooding will occur. First up, historic records, as the name suggests, identifying the areas which have been flooded the most frequently and most severely. Next up, accurate forecasting of possible hazard events. So, for example, if you know that a tropical storm's coming, then that might quite likely lead to a storm surge. And if you have an earthquake, then there's an increased likelihood, obviously, that a tsunami might occur. And this will also enable you to make predictions about the potential strength and scale of a particular event. Now we're going to explain how prevention strategies can reduce the impact of coastal flooding. Starting with hard engineering strategies, e.g. flood defences built along the coastline, help reduce the severity of flooding. Another example of a prevention strategy is restricting where buildings can be built. Because clearly, if you're not building where coastal flooding is likely to take place, then that limits the amount of damage. And this therefore reduces the potential economic impact of a flood. Early warning systems now may give messages through the Environment Agency which will help people evacuate if necessary, preventing potential loss of life. And then alternative strategies include building emergency centres for people to shelter in, reducing the number of people who might be killed. Now we're going to move on to hard engineering coastal management strategies. As a summary, hard engineering strategies are usually made using concrete or steel. They tend to be human-made and usually cost a lot to build. And they work very much against natural processes. The examples of hard engineering strategies I'm going to take you through include groins, revetments, sea walls, gabions, and riprap. And these are all examples of hard engineering strategies. So here I am on the BBC Bite Size website, and we can see very clearly pictures of wooden groins. These are barriers built at right angles to the beach, and you can see how they trap sediment between them, which help build up a larger beach which can absorb wave energy and therefore reduce erosion. So obviously the good thing about groins is they're highly effective at absorbing wave energy and reducing erosion, but clearly by trapping the sand they starve areas of coastline further down the coast of sand, which may lead to further erosion in these areas. So a sad thing about groins is by trapping sand, areas further down the coastline are starved of sand, leading to increased erosion in these areas. Next up, revetments. So now I'm pinging to Wikipedia and we're looking at revetments. These are sloping structures built on embankments or shorelines along the base of the cliff, and again they will absorb wave energy and reduce erosion, but I think we can agree they're pretty aesthetically unappealing, i.e. they're super ugly, but they are very effective. Obviously once they start rotting then they'll need replacing, which will have a large impact in terms of cost. Because they're made from wood, they're a fairly low cost solution. And again, we can steal this point here saying that they absorb wave energy and reduce erosion. But the sad thing about them is that they are aesthetically unappealing. Sea walls. So here's a sea wall. These are concrete barriers that limit the effect of coastal erosion, and they're very good for reducing damage to high value land. They're hard wearing, but they're usually the most expensive option, and obviously over time they can become eroded themselves, so they need maintenance. So they limit damage to high value land. They're hard wearing. They're expensive to install and need maintenance. And this is what you'll find is common with all hard engineering strategies, is the level of maintenance they'll all require. gabions. Now here's a gabion. You can see that a meshwork is created, usually out of steel, and that these will contain rocks. Again, the thought process behind this is that it will help absorb the wave's energy and prevent erosion. So they'll absorb wave energy, reduce erosion. They're cheap and easy to build, but a lot of people find them aesthetically unappealing. Last up, riprap, rock armour. Large rocks or boulders are placed in front of the cliff. They act to absorb wave energy, reducing erosion. People tend to find this more aesthetically pleasing because they look more natural than a concrete wall. But the disadvantage is that strong waves can cause the boulders to move, meaning they need to be replaced. Moving on to soft engineering coastal management strategies. So unlike hard engineering strategies, they work with natural processes. So if you remember sea walls, revetments, riprap, they absolutely do not work with natural processes. They work very much against them, whereas soft engineering strategies are the total opposite. And because of this, they're usually cheaper. And they look natural, but not as effective at preventing coastal erosion compared with hard engineering strategies. We're going to be looking at the following soft engineering coastal management strategies in more detail. So beach replenishment, cliff regrading, ecosystem rehabilitation, sand dune nourishment, otherwise known as revegetation, and managed retreat. So beginning with beach replenishment. As the name suggests, sand is placed on a beach to create a higher and wider beach, meaning that more wave energy can be absorbed, thus protecting the land behind. So what are the various advantages of this? Well, it's a sustainable approach. The fact that you're creating a larger beach means that it's likely to be more appealing to tourists. A big disadvantage is that the sand needs to be transported to the site. Next up, cliff regrading. This is when the steepness of the cliff is reduced, meaning that it's less vulnerable to collapse. Good things about this is that it's fairly low cost, and again, it's sustainable. Bad things about it is that it involves the loss of part of the cliff. And whilst doing this, the cliff itself may collapse, particularly if it's unstable to begin with. Ecosystem rehabilitation. So this is planting vegetation and restoring natural processes. Advantages of this is that it enhances the natural appearance, so it's a nice, pretty approach to preventing coastal erosion as opposed to building something like a seawall or fitting gabions. It's highly sustainable and it will prevent erosion because remember, those plant roots will help hold down the sand. It does require maintenance, and again, it's not going to be the most amazingly effective way of stopping erosion. Sand dune nourishment. Specifically, this is planting marram grass, which remember is commonly found on sand dunes. Highly specialised plant. The grass traps the sand and it provides a barrier between the sea and land. It's a fairly cheap process and approach, and again, highly sustainable. Disadvantages, again, there's no guarantee that the sand will remain in place. And they are very, very fragile ecosystems. Sand dunes may be damaged by storms, people trampling, tourist activities. Managed retreat now. This is when some areas of low value land are just allowed to be flooded. So basically we give up in these areas in terms of trying to stop the sea doing its thing. And because that water is seawater, you're going to produce a salt marsh, which is a very valuable habitat for birds and vegetation. We're going to be providing a natural barrier between the sea and land. Where that land is owned by landowners, they'll require compensation. Not that that's particularly a bad thing, I'm just writing it here. Because effectively they're losing their land to the salt marsh. So a tropical cyclone is an example of a hazard. A hazard is an event which causes damage and destruction to people, their property, settlements, infrastructure, and good examples of hazardous events include earthquakes, tropical cyclones, flooding, and volcanoes. But we are going to focus in on a tropical cyclone. So starting with the characteristics of a tropical cyclone, you'll expect to see firstly a huge whirlpool. This is a gigantic mass of revolving moist air there'll be an eye. Now, an eye is a very, very eerie place. The eye of the storm, the eye of the tropical cyclone, is an area spanning around 40 kilometers where you'll actually find little to no rainfall and low winds. But surrounding the eye is what we call the cumulonimbus clouds. These are huge towering clouds that surround the eye, and here you'll find extremely high winds, high rainfall, and in fact the winds can blow as strongly as 320 kilometers per hour, and they're going to be responsible for a lot of the damage associated with tropical cyclones. A couple of important definitions now, starting with wind shear. This is a change in directional wind speed over either a horizontal or vertical distance. Next up, the Coriolis effect, or Coriolis force. This is due to the Earth's rotation. It means we experience an apparent force, and depending on which hemisphere, this force will act in a particular direction. So in the northern hemisphere, the Coriolis force deflects the wind towards the right, and in the southern hemisphere, the Coriolis force deflects the wind direction towards the left. So what conditions do we need for a tropical cyclone to form? First of all, we need the warmth and moisture associated with warm oceans found in the tropics. So we're looking at tropical cyclones forming near the equator with warm water temperatures of at least 26 degrees Celsius. You'll also find low air pressures in the tropics, and low air pressures are needed for tropical cyclones to form. The importance of the low air pressure is that it pulls water high as the cyclone gathers speed. Obviously, you'll need the presence of the Coriolis force, which will be in effect present always because of the Earth's rotation, but that will influence whether the tropical cyclone winds are blowing towards the right or towards the left. You need a low wind shear because with high wind shears, you'll remove the moisture and the heat needed for tropical cyclone formation. So what damage do tropical cyclones cause? So remember, what do we get with a tropical cyclone? High winds and high rainfall. So then think about, well, what will high wind cause? So the strong winds associated with a tropical cyclone will obviously cause damage to people's settlements, their property, their crops, as well as transport infrastructure. Heavy rainfall causes flash floods and landslides. Storm surges associated with low air pressure may flood low-lying land, destroying infrastructure and property. And remember, the direction that the tropical cyclone will move will be dictated by the direction of the prevailing wind, as well as influenced by the Coriolis effect. Now, the impact that the tropical cyclone has on a particular area depends very much on the level of development. So, are there early warning systems in place telling people that the tropical cyclone is expected? Can people move to safer places? What kind of infrastructure is in place? Are the buildings reinforced? How high or low-lying is the land? Obviously, low-lying land will be more susceptible to storm surges and the flooding associated with that. If you're looking at areas with higher urbanization, so more housing, will obviously be more affected by tropical cyclones compared with agricultural areas, although obviously these places will see damage to their crops. Let's touch on the devices used to measure tropical cyclones. So you've got the Saffir-Simpson scale. Weather stations and satellite systems, as well as anemometers, will help you monitor the formation of tropical cyclone and how likely they are to occur. Identify one characteristic of a tropical cyclone. So remember, I talked about the fact that you have that eye of the storm with very low wind speeds, low rainfall. You have cumulonimbus clouds, and you have a gigantic whirlpool. What do we have here? We can see area of very high pressure. That's wrong. Remember, it's an area of very low pressure, very little rainfall. That's only true of inside the eye. It's not true for the whole tropical cyclone. Low wind speeds, no, it's high wind speeds. Again, the exception being the eye. So the answer here is D. State one factor that can affect tropical cyclone formation. I'm just going to pop here the Coriolis effect. Remember, that's the effect of the Earth's rotation on the direction that the winds blow. You could have also said warm sea temperatures. Remember, we need a minimum of 26 degrees Celsius, wind shear, air pressure, climate. Explain one long-term impact of a tropical cyclone. So anything sensible here. Let's just talk about damage to infrastructure caused by the very high winds, which requires heavy investment from the government to fix. You could have also mentioned people's homes are destroyed, leading to homelessness and therefore the development of makeshift settlements. Explain 2 reasons why people continue to live in areas at risk of tropical cyclones. So why do people continue to live in areas where tropical cyclones occur? Well, first of all, they may be aware of the risk but accept that as part of the life of that area and do not feel that the danger to themselves and their lives is a big enough reason to prompt them to move out. Another reason people live in areas at risk of tropical cyclones is that people may be financially unstable, so have no choice but to stay. Now I want to talk to you about earthquakes. We'll start with earthquake formation. So what causes an earthquake? Well, you need an oceanic plate and a continental plate. They move towards each other. The oceanic plate is denser than the continental plate, so it is subducted under the continental plate. It's forced underneath, and there's a buildup of friction which is released at that plate boundary in the form of seismic waves which are felt. Now, the center point of the earthquake is known as the focus, and then the point on the Earth's surface directly above the focus is known as the epicenter, and that's where the strongest seismic waves are felt. What device is used to record the size of an earthquake is known as a seismograph, not to be confused with the scales used to measure the intensity of an earthquake. These are known as the Richter scale, the moment magnitude scale, MMS, and the Mercalli scale. Earthquakes form at destructive plate boundaries, and that's because the oceanic plate over time is getting destroyed as it's subducted under the continental plate. I'm sure you're aware, but one result of an earthquake is the formation of a gigantic wave known as a tsunami. So how do tsunamis form? Tectonic plate movement can trigger an earthquake which releases shock waves. Those shock waves cause waves on the sea's surface. When the wave splits, it then becomes amplified as it approaches the shore, generating the huge waves you associate with a tsunami. As we've already mentioned, earthquakes occur along tectonic plate boundaries. 80% of earthquakes occur around the Pacific Ocean, where the Pacific plate is being subducted beneath the surrounding plates, and that's why this area is known as the Pacific Ring of Fire. So what sort of damage do earthquakes cause? Obviously, any tsunamis that are generated flood low-lying land, damaging infrastructure, people's homes, destroying crops, and again, simply the tremors caused by the earthquake may do exactly the same here. This leads to homelessness, it leads to governments needing to rebuild infrastructure, it leads to the development of makeshift settlements. It can lead to damage to water supplies, gas pipelines, electricity pylons. Why are some people more susceptible to tectonic hazards, such as earthquakes? Well, first of all, if they live close to a plate boundary, clearly, as I've already said, plate boundaries are where earthquakes occur, so therefore these people will be more likely to be affected compared with people who live in the centre of a tectonic plate. Population density also has a huge role to play. Mega cities contain huge numbers of people, and therefore large numbers of people are likely to be affected in the event of an earthquake occurring. Some countries are more vulnerable to earthquake events compared with others. This is often due to money, so there could be a lack of early warning systems in some countries, meaning that people don't know when they need to leave their homes, when they need to move to safer areas. You could find that in places with less money that the buildings aren't reinforced appropriately with concrete exoskeletons, meaning they're more likely to collapse. This kills people and also means that their homes are more likely to be destroyed. Even in the event of the earthquake occurring, different countries have different responses, so differing abilities to treat injured people, to evacuate them to safer areas. Let's list the short-term impacts of an earthquake. So damage to infrastructure, damage to crops, damages to services such as hospitals. There could be tsunamis due to the shock waves occurring under the ocean. There could be landslides, mudslides, flooding. This will be likely due to the tsunami. The longer-term impacts of an earthquake are largely the financial costs, repairing services, infrastructure, damaged roads, And I'm going to run you through a past paper question that really looks in greater depth at the short and long-term impacts of an earthquake. Study figure 3C in the resource booklet, analyse the short and long-term impacts of the earthquake event. We're going to give an overview using our knowledge, what we've studied in class, on our own, reading textbooks, etc. We're going to discuss all the short and long-term impacts of earthquake events, and then we're going to analyse, that means use the information provided in figure 3C to look at the extent to which this particular earthquake event affected people both in the short and long term. So we'll start with a general statement saying that there's a range of short and long term impacts of earthquakes, and these vary due to the size and intensity of the earthquake as well as the location. It's always worth writing this sort of thing to begin with in this type of question. So we'll start with general statements about short-term impacts. Include tremors, which damage buildings, shatter glass, etc., which could lead to debris. This may kill and injure large numbers of people. Long-term impacts now include homelessness, contaminated water supplies. This means that a government will need to spend lots of money fixing these issues. And now we're going to check out figure 3C. So in order to maximise our chance of getting 8 marks in this question, we really need to look in depth at figure 3C, which shows details about an earthquake event in Haiti, a developing country, in 2010. So we're going to work our way around the figure, starting here with this key, perceived shaking. So obviously the darker the shade of blue, the more extreme shaking that the area receives. So you can see that violent shaking is experienced down here at Port-au-Prince, Carrefour, Gressier and Ligan. So I'm just going to make a note here that a large area experiences violent shaking, and name a place such as Port-au-Prince. So we're really focusing in our answer on figure 3. We'll now look at this table. We have a population of 9.95 million, short-term impacts, 220,000 people killed. Goodness me, that's absolutely horrific. So massive number of people, 300,000 people injured on top of that. So really fleshing this out, a large number of people affected. And that's a short-term impact. Now let's look at the longer term impact. 2 million people with poor access to food and water. Obviously that's going to have huge knock-on effects. 1.3 million people homeless. And we can see outbreaks of cholera, and that will be due to the poor access to clean drinking water, potentially poor sanitation. So we can see huge disruption to infrastructure. So let's start to write out our answer now. So figure 3C shows that a large area of Haiti was subjected to violent shaking, e.g. Port-au-Prince. There were severe short-term impacts, and we're going to list how many people died. 220,000 people died, and 300,000 people were injured. Long-term effects include water contaminated with cholera and a large number of people made homeless. You can really point out that figure 3C, constantly refer to the figure so they know that you're using the data, suggests a high level of disruption to infrastructure. As with tropical cyclones, why do people continue to live in areas which are susceptible to earthquakes? Primarily because despite the fact that they know the risks, they may not have the financial means to move away from a particular area. They could have established their families, they don't want to leave them. Remember, places where there's high population, so mega cities, are going to be more susceptible to the damage caused by earthquakes. Now I'm going to take you through preparation for earthquakes, such as warning and evacuation, building design, remote sensing and GIS. So I'll take you through a past paper question, first of all, for building design. This says one way, but I want to give you several examples. You want to talk about steel frames that sway during an earthquake. You could talk about rubber shock absorbers in foundations. So through both of these things, you'll find that buildings are less likely to be damaged during an earthquake and less likely to create debris. You could talk about buildings having lightweight roofs. And safety glass and windows. This is important because you're going to find that during an earthquake, the safety glass, or glass indeed, will smash, and that's obviously going to be awful for anyone walking beneath the building. In this way, you're going to reduce the number of injuries. You've got things like concrete exoskeletons and steel meshwork. Strengthen buildings. And help reduce the likelihood of them collapsing. As well as building design, governments can carry out emergency drills. This involves the population practicing what to do in the event of an earthquake. Also involves telling them where they should go. The purpose of this is to increase the chance of survival. Also key are evacuation plans. These are shared with the population. Again, so that people know what to do in the event of an earthquake. Let's talk about GIS now. This stands for Geographic Information Systems. And crucially, these can be used before, during, and after a hazardous event such as an earthquake. So there's a wide range in which GIS may help. It can help you identify road structures. And actually, I'm going to create a mini mind map. Mind maps are not my favourite thing, but I think in this case, when we discuss how GIS can be used to manage earthquakes, I think it's going to be the most beneficial way I can display this. So GIS allows roads to be identified which enables emergency aids such as ambulances, food and water supplies. GIS also provides maps which can be shared with all support agencies, therefore enabling a more coordinated relief effort, ensuring that resources are not wasted and get to where they need to be much faster. GIS can also enable you to identify where services were before the earthquake occurred and therefore where they can be built afterwards. So the earthquakes occurred. What types of short-term relief exist to help reduce the impact of the earthquake? You've got tents, which provide shelter. You've got food parcels, reduce the risk of starvation. Because that food is free. You've got emergency medical aid is used to treat injuries caused by falling debris. And bottled water, that's key when lots of water sources will have become contaminated. And that reduces the risk of contracting cholera. Now we're going to discuss longer term planning. So this is the approach that governments can take in order to reduce the impact of earthquakes. So an important one here is hazard mapping. This involves risk assessments being made, which inform town planners of really two things: which buildings need reinforcing and where to avoid building on. Explain why earthquakes occur at destructive plate margins. We need 4 marks here. So our first mark is to say that the oceanic and continental plates move towards each other. The denser oceanic plate is subducted or sinks beneath the continental plate and melts. There is friction which builds up until seismic waves are released. Identify which of the following can be used to record earthquakes. It's going to be a seismograph. Don't be confused with the Richter scale. Remember, that's used to measure the size of an earthquake. The key word here is record. Suggest 2 reasons why some places are more vulnerable to tectonic hazards compared with others. So obviously the closeness or proximity to a plate boundary, the closer you are, the higher the chance of experiencing an earthquake hazard. And then population size and population density is also going to be important, because obviously where people are more densely living together, they're more vulnerable to hazards such as earthquakes and buildings and infrastructure collapsing on them. Explain one strategy to reduce the impacts from earthquake events. Clearly, early warning systems. If people know that an earthquake is due to occur, it allows these people to evacuate, which could therefore reduce deaths. So there's the 3 points we need to make for the 3 marks. You could have also mentioned building earthquake-resistant buildings, such as a concrete exoskeleton, which reduces damage caused by the ground shaking during an earthquake, which would result in less injuries. Now we're moving on to volcanoes. So I'll be talking about their characteristics, their formation, and their distribution. So first of all, to summarize what a volcano is, it's a vent in the Earth's crust, as we can see here, through which magma flows. This is molten rock, and it flows over the Earth's surface where it cools to form volcanic rock. And obviously as these layers build up, you get that characteristic cone shape that you find with these composite volcanoes. Now, volcanoes expel gases, ash, and solid volcanic rock. But how do volcanoes form? They occur at both destructive and constructive plate boundaries. Here we see a destructive plate boundary. What occurs here is that two tectonic plates push together until one is subducted, which means forced beneath the other one. As the plate is pushed down, the rock melts. This builds up pressure underneath the Earth's surface and means that magma can be forced through faults in that crust. So I'll just write out the summary here. So to summarise the volcano formation at a destructive plate boundary, we have our two plates pushing together until one is subducted. As the plate is pushed down, the rock melts and builds up pressure in the Earth's surface. But what about volcano formation at a constructive plate boundary? So I think that this type of volcano formation is slightly more straightforward. Here you'll find that the plates are moving apart, so the tectonic plates diverge, they move apart, and magma rises up in order to fill the gap, and there you'll find your volcano may erupt. Just a tiny extra detail here, they could ask you, how do hotspots lead to a tectonic hazard such as a volcano? So we're just going to say here that a hotspot, they are stores or plums of magma that are pushed through a weakness in the Earth's crust to form volcanoes. Let's talk about the distribution of volcanoes. You're going to find them concentrated along tectonic plate boundaries, as we see here, and specifically around the Pacific Ocean, where the Pacific plate is being subducted beneath the surrounding plates, and that's why we call this the Pacific Ring of Fire. Now we can measure the intensity of a volcano hazard using the Volcanic Explosivity Index. Now it's time to turn our attention to the characteristics of volcanoes. So we'll be going through things like lava flows, ash clouds, lava bombs, etc. So starting with the lava flow, these may reach as far as 10 kilometers from the volcano crater. They'll destroy farmlands and buildings, but lives are rarely lost. Now ash clouds. These are thrown into the air during a violent eruption. They may be carried long distances by wind and cause adverse effects in other countries. A good example of this is the volcano eruption in Iceland in 2010, which caused mass travel disruption to many countries hundreds of kilometers away. Ash may bury buildings and crops and cause suffocation or asphyxiation of animals and humans. Now, volcanoes belch an awful lot of toxic gases when they erupt. These include sulfur dioxide, carbon monoxide, and even cyanide. So these are highly toxic gases. Carbon dioxide is also released, but it's not toxic. But it is a greenhouse gas which can contribute to global warming. Sorry about how I've written those symbols, but I am a chemist, so that's why I've written the chemical formulae of those gases. What about lava bombs? Now, these are terrifying things. Due to the buildup of pressure, large boulders of lava may be emitted at high speed, causing severe injury and death to any animals or humans caught in their path. As we previously mentioned in another video, obviously the tectonic plates moving can be a major source of earthquakes, so it's common to get earthquakes where you find volcanoes. Pyroclastic flow. This is a fast-moving current of hot gas and lava, which moves at high speed along the ground away from the volcano. This causes damage to crops and buildings and may lead to serious injury and death. And then lastly, mudslides, maybe not one that you think of immediately, but they commonly occur in places which have been littered with volcanic material. Now we're answering the question, why do people continue to live in places at risk from volcanoes? Well, one very good reason is because of the quality of the soil found close to volcanoes. That ash which gets deposited increases the fertility of the soil and therefore produces good crop yields. So increased crop yield. Serious eruptions may be considered to be rare and therefore not considered a serious threat by residents. Tied in with this first point, the quality of the soil, volcanic areas are often rich in mineral deposits, which provides people with a potential source of income, hence they choose to stay. And then it's that matter where so many people have historically lived in an area, they have so many settlements present that the family connections people build mean that they do not want to leave the area in spite of all the risks. And then when you've got that open vent with the access to the magma, it means that you have access to geothermal energy, a type of renewable energy resource that provides people with a low-cost source of energy. Now, this bit of the specification deals with the reasons for differing impacts of particular volcano events. So why does one particular volcano erupting cause very few deaths, very little damage to infrastructure, whilst other volcano events cause huge amounts of damage and destruction? So the first point is obviously the location, size and length of the eruptive episode will have a huge influence, as well as how prepared local areas were for the eruption. We've already pointed out the various characteristics of volcanoes, so you're not guaranteed all of these characteristics when a volcano erupts. So we know that some volcanoes produce more ash, which causes travel disruption very long distances away when we take that Icelandic volcano eruption back in 2010. Some produce more pyroclastic flow. Which cause a lot of injury and death to animals and humans. The impact of a volcano will depend on how much preparation has taken place beforehand, how much warning they got that it was going to happen. So level of preparedness. Local emergency services in situ, so waiting to come and rescue people, as well as warnings telling people to evacuate. That will reduce the number of deaths from the volcano. Population density is also very key. Obviously, if you've got huge megacities or even just large settlements close to the volcano, they're going to be more vulnerable to any of the lava flows and pyroclastic flow, as well as ash clouds.